Hey, fifth graders. Today we're going to be learning how to multiply a decimal by a decimal. What you see here in the boxes below is the standard algorithm, probably the way Mom and Dad learned it, definitely the way Mr. B learned it. And what you're going to see here is I'm going to show you the standard algorithm, and then I'm going to also show you how to identify the answer or the product with the model. Okay, so we'll do both. On the next slide, we'll go over the standard algorithm. These are the steps for that. This would be a good point to pause the video and get these steps in your journal. They're going to be valuable. Make sure you get all 4 of them. And we'll go ahead and practice these steps in the next slide. Okay, so now it's time to practice the standard algorithm using the steps from your notes. I have them again here at the bottom, and we'll kind of bring them up as we do each step so you can kind of see what they look like. So first, let's write the problem. We're going to have 2/10 multiplied by 8/10. Now the first step says line up the digits to the right. And it's important to notice that it says digits and not decimals. Okay, because when we're multiplying decimals, we don't necessarily have to have them lined up. And on this case, they will line up because the numbers are small. But as we get into bigger numbers, the decimals don't have to line up, but the digits do. Okay, so just keep that little note in mind. So let's write that and line up the digits to the right, which would put the 2 and the 8 here are both decimals. And we're multiplying those. Okay, we did that step. Good job. Step 2, multiply using standard algorithm. That's right here. So that's just no models, no squares. It's just straight up multiplication facts. And this is actually a multiplication fact because it's 2 times 8. So I put Bob in parentheses there because if we're dealing with a bigger number, a 3 by 2, Bob will definitely have to come do his job. But for this simple problem, we don't need it. It's just 8 times 2, and we know that the product for that is 16. So that step is complete. Let's move on to step 3. Step 3 says count place values to the right of the decimal. Another important thing to note here, it says count place values. Another way to look at that would be to count digits or numbers to the right of the decimal. So we see the decimal here in 2/10, and we see the decimal in 8/10. And we're going to count all of the digits past it. So here there's 1 digit, and on this one there's 1 digit. That gives me a total of 2. So there's 2 digits after those decimals. And now that step is done, and it's going to be done in yellow because I don't want to change colors right now. And step 4. Step 4 is move decimal to the left to make the product smaller. Move decimal to the left. Oh, so the product, right? That's our answer. So here's our product here. And it says move decimal to the left to make the product smaller. Well, because 16 is too big, right? 2/10 and 8/10, there's no way that can be the whole number of 16 because 2/10 and 8/10 are very, very small. So 16 is actually not correct. It's a smaller number. And remember from a previous lesson, moving the decimal to the right makes the number bigger. Move the decimal to the left makes the number smaller. So we're going to start here in this spot as if this was a whole number. And since we counted 2 digits after the place values of the decimal, then we're going to move this 2 digits in and drop our decimal right there. So our answer is, in fact, 16/100ths. And that is a standard algorithm. I'm going to show you what that looks like in the model on the next slide. All right, fifth graders, here we are with the model. We have our equation that we just worked out in the other slide, 2/10 times 8/10. And now we're going to be showing you what that looks like in the model. On the bottom here, I put a reminder just so you can remember what 1/10 and 1/100th look like. 1/100th is just one of the little boxes, and then 1/10 is the whole row of boxes. Okay, and that'll come in handy when you look at the multiplication for the next couple of slides, right? So this one is 2/10 multiplied by 8/10. So that's going to look like the one with the red arrow. That's going to look like a tenth, right? So I'm going to shade in on my model. I'm going to shade in, let's do 2/10. So usually we're going to do this one first, and we're going to go down. Remember, a tenth is a whole row down, so I have to shade in all of these. That's 1/10, and I need 2/10, so let's do one more. And this could probably go faster, but this is as fast as we can go. Okay, so I have my 2/10. I got that. Now I need to do my 8/10. But what I'm going to do, since I'm multiplying, is I'm going to crisscross these. And what I mean by that is my 2/10 went down this way, right? I went down. I counted the columns down. My 8/10, I'm actually going to go this way. So I'm going to shade in my 8/10 going horizontally instead of vertically. So let's do that now, and we're going to shade in 8/10. And when I do shade in 8/10, remember that you're shading in the whole row because you can kind of see it. It's kind of light, but you get the idea. And we're going to do 8/10 of that. Okay, I want to pause and go into fast forward mode so you don't have to watch me shade in all these boxes. Stand by. And through the magic of time travel, I have officially shaded in my 8/10. Right, so I have 2/10 going down, and I have, let's just erase this. I have 2/10 going down. Maybe I can make these arrows look a little bit neater. Come on, Mr. B, let's get it together. And then I have 8/10 going across. Well, maybe not. I thought there was arrows on here, but apparently I'm wrong. So I'll have to just deal with my sloppy arrows. Sorry about that. So 2/10 going down this way, and 8/10 going across this way. And I know they're tenths because the whole thing is filled in all the way down and all the way across. And what you're going to notice is the 2/10 and 8/10 where they overlap, there's a different shade there. It looks a little orangey, right? A little orangier than the other one, which is cool because now I can take my blue and I'm going to highlight this orange part here so you can see. This is the part that overlaps. And guess what? If I count those hundredths, I'm going to get my answer, right? So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's 16 hundredths. So I have my decimal, tenths, hundredths. That means my 16 would go like this. And my answer is 16 hundredths. So you see through the overlap method, I was able to find the product. In the first slide, we just did standard algorithm, which is easier for some people. And some people like to see it in a model, which is what we did here. Okay, let's do another one. Okay, guys, on this one, we'll just do a standard algorithm, and then we'll model the answer. So we have 8/10 times 5. We'll line everything up to the right. Times 5/10, and 8 times 5 is 40. Okay, but I know that number's too big because I'm dealing with numbers less than 1. So count the place values after the decimal for both of them. There's 2, so I need to start here and come back and make my number smaller. And I end up with 40 hundredths. So for my model, we're going to use a highlighter here. See if we can go maybe a little bit quicker. For this model, I'll do my 8/10 going down. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. Oops, let's try that one again. 8/10. Perfect. Now we'll use a different color and we'll go the other way with 5/10 here. 1/10, 2/10, 3/10, 4/10, 5/10. Then I can outline my overlapping area, which would start I guess I could start here and outline this overlapping area. And in there, I should have 40 hundredths. Let's see if I do. 1, 2, 3, 4, 5. Okay, so I can count by fives. 5, 10, 15, 20, 25, 30, 35, 40. 40 hundredths. Very good. Okay, for this one, I'm going to model and let you solve the algorithm. So I have 6 tenths. So we'll go down 6 tenths, 1 tenth, 2 tenths, 3, 4 tenths, 5 tenths, 6 tenths, and the other way we'll go 7 tenths. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths. And then if I outline my area that are overlapping, which would start here and go up here, within this outlined area will be my product. So I'll let you count those up, and while you do that, I will write the standard algorithm, and you can put your answer in the comments below. Don't forget, these are less than 1, so the answer cannot be a whole number. It's got to be smaller than a whole number. Good luck. So here we have 5 tenths multiplied by 1 and 7 tenths. And if you remember from a previous lesson, we know that multiplication means of. So 5 tenths of 1 and 7 tenths. And 5 tenths can actually be looked at as a half as well. A half. So a half of 1 and 7 tenths. So because I have a half of 1 and 7 tenths, I'm going to do the whole number first. So let's model that 1 and 7 tenths and show what that looks like. Okay, so here you have my model of 1, and here's my model of 7 tenths, okay? So there's my 1 whole and my 7 tenths. Now let's go the other way and look at 5 tenths of both of these, because the 5 tenths or half is of 1 and 7 tenths. Okay, here you see I have my 5 tenths here and my 5 tenths here. So we're looking for the overlapping portion. So let's find that overlapping portion, and we can see if our product, what it will be. So here's the first, actually that's not true. Here's the first overlapping part, would be this whole entire half. And then on this side, the overlapping part is only this much. So if we add those two together, we should get our product, right? Now let's do a standard algorithm. I think this is a good part to do that. And we'll see if we can match our standard algorithm answer or product to the model of what it looks like. So remember, step 1 is to line all the digits up to the right, which we did that. There's a 1.7, and we have a 0 here. Okay. Now, this looks a little funky. Maybe I could rewrite it so that it looks like more like what I'm used to. And then multiplication, I can do that. That's fine. I have 2 decimals in each number, although I'm make sure that I put them all to the right to line up the digits. There's a 0 here, but we don't actually need that 0 because it doesn't hold any value at that spot, right? So we'll just leave it out and just leave our 5 tenths there, multiply. Okay, and then we use standard algorithm, 5 times 7, which is 35. 5 times 1 is 5, plus our 3 gives us 8. And do you remember the next step would be to count the digits after the decimal to the right of them. I have 1 here and 1 here for a total of 2. So we'll take our number and we have to move the decimal to the left to make it smaller and drop it there. So my actual answer is 85 hundredths. So my model should show that. So let's see. I have, let's go this way for tenths. 10, 20, 30, 40, 50. So there is 50 hundredths there, or 5 tenths. And on the right side, I have 1, 2, 3, 4, 5. So I can just actually count by fives, right? There's 5, 10, 15, 20, 25, 30, 35. So I have 35 hundredths there. So I have 50 hundredths on the left side and 35 hundredths on the right side. And I can add those two together. We'll just do that right up here. And for adding and subtracting, I do have to line up my decimals. So confusing. 5 plus 0 is 5. 5 plus 8 is 8. And since I'm adding, I just bring the decimal straight down. 85 hundredths matches what I got on my standard algorithm. Very good. Next slide. So this one's a little tricky, and you're going to have to really wrap your head around the model, okay? Maricela used this model to represent one whole. So this model here is what Maricela is saying equals one whole. Now we know that usually when we deal with a whole number, our model is going to look like this. It's going to look like a big grid. And that's okay. That's the way it should look. But for the purpose of this problem, Maricela, who I guess she's a little exotic, eccentric, because she decided to use this tens bar as a whole, which is fine. She must be working out something that we don't understand. Let's see what the question is asking us. Which model represents 1 and 8/10 multiplied by 4? Oh, we've seen this before. Do you remember when we did these and we said that that's 4 groups of 1 and 8/10? So looking at the answer choices, do I have any of the answer choices that have 4 groups? Nope. Nope. Well, this one does have 4 groups. 1, 2, 3, 4. But it's not 4 groups of 1 and 8/10. H has 1, 2, 3, 4. It does have 4 groups. And if I'm going by Maricela's model, let's make this bigger. If I'm going by Maricela's model, then this is a whole, and this is 8/10. So then this model does represent 1 and 8/10. 4 groups of 1 and 8/10. So my answer would be H. Good job, guys.